Welcome back. So this is A level computer science 9618 and this is chapter 8 database, right? So let's start with this file based approach. The situation where data is stored in one or more separate computer files defined and managed by different applications programs. So in a file based approach we try to store the data in different files, and we try to just take care of the data and playing with files and manage, which is also managed by different application programs. Okay, so what are the drawbacks of using the file based approach as compared to using a relational database? So limitation of file based approach for the storage and retrieval of data redundancy. There could be a duplication of data, right, which could also waste time and storage. Some information may be duplicated in different files. This lead to data redundancy. Security problems. Each user should be allowed to access data concerning his requirement only, which means there should be only specific users which could access those data, right? So that's a really important, because we don't want any person just try to access the data and could somehow try to steal that data from any particular organization, right? We also want a fixed query. We also want queries, okay, a very amazing queries, but it is very fixed in when using file based approach, which is not good. Programs are written to satisfy particular function. Any requirement needs new program. So if you want to know, if you want any different kind of queries, we would really want to make a new program for that requirement. Incompatible. Okay, so programs are written in different languages. Like first language is written in Java, the other language is written in Python. So yeah, there could be uh, you know programs can written in different languages, so it cannot easily access each other's files. So instead of using file-based approach, which was very old method in those days, a new method was developed, which is known as a relational database. And in a relational database, you can easily do queries. The security is also very good. There's no data redundancy, and obviously, and relational database, we can make so many tables, and all these tables can be connected to each other. They could have a relationship and all the good stuff. So it allow concurrent access. Program data dependence is overcome. Okay, there is no program. Okay, yes. Reduce data redundancy. Data integrity is improved. Data integrity means ensure data is consistent, accurate. Validation rules, input mark, refresh integrity, making sure that table do not try to reference data which does not exist. A primary key cannot be deleted unless all dependent records are already deleted. Complex query can easily be done. Adding or removing of fields easily made. Security is improved. Data privacy is maintained. Okay, so it is a collection of relational tables. Separate a huge amount of information into numerous tables. You're throwing a huge amount of data and then converting into so many tables which have a relationship, and they are easily maintained, and you can also do queries. There's data privacy, there's security, easy adding or removing of fields are easily made, and reducing data redundancy. Yes. So talk for a relation tables for relational database are linked through the use of keys, primary keys, foreign keys, composite key, candidate key. Okay, each table may have one primary key and any number of foreign keys. So whenever we have two tables, one table has the primary key and the other has the foreign key in order to connect. Okay, so let's see the terminologies. Entity means any object, person, or thing about which it is possible to store the data. Okay, data is now this is very valuable data. Okay, because now in this modern world, people, when for example if you have downloaded the app and that app is asking for permission about this and that, it could be possible that this app is giving you a free service, and in return it will try to sell out your data, your personal data, to the third party, and one data for one penny. So in this modern world, data is very important. So storing the data, managing that data, you definitely need more capable methods like relational database. So entity, any object, person, or thing, anything you can think of. If you're not buying a product, then you are the product. Same thing here. Any object, person, or thing about which it is possible to store data. Yes. Record, which is a row. Field, which is in a column. Tuple, a single row of a table which contains a single record. Like for example, if you want to know the person that you're trying to find the ID number 5090, right, and you just look in the field, you'll get 5090, and it will take out the whole record for that relation. Okay, a single row of table which contains a single record for that relation. Attribute is column. Primary key attribute or combination of attribute that is used to uniquely identify the record. Candidate key is a combination of that can qualify. Primary key that is used, and candidate key which can qualify as a unique key. Okay. Secondary key is that is based for retrieval of data is called secondary. It can be a non-unique key. Okay. So secondary key is a non-unique key. Candidate key is those attributes that can qualify as a unique key. Primary key are those which are used to uniquely identify a record. Okay. Foreign key is simply a primary key from one table that has been placed in another table. Okay, that's a foreign key. Composite key is a primary key that consists of two or more attributes, is known as composite key. Indexing, it is a data structure that improves the speed of data retrieval operations on a database table. Okay. So this was the difference between file-based approach and relation database. We have done the terminology. Let's see the ER diagram. So ER diagrams really help us to understand to describe the relationship between any two or more tables. Okay, these are the kind of relationship that we could use: one, many, one and only one, zero or one or many, zero or many. Most of the time these two are used: one to one, or one to many, many to many, many to one, right? For example, you have these tables and you want to know the relationship. So this is the class ID, this is the teacher name, and this is a student ID. So this could be one to many. Yes, definitely this is one to many, because they are student. One class is connected to all student, right? One class is connected to all student. All student is connected to one class. All students sit in on one class, right? Many to one function. You also have to write down the relationship. Okay, this is a many to one function, many to one function relationship. Many to one relationship. The database design has 3 tables to show the qualification and grades each table has attained. Each student has attained. The following is a sample of the data from each table. Student, this is the student ID table. This is the qualification table, and this is the student qualification. And right now you can see here that how these are connected. So this is the primary key of this one, and you got the primary key of this, and now the both are the primary keys are in here, which is known as a foreign key, right? So what should be the relationship? Obviously, by seeing here, you can just easily say that it's a one to many relationship. Student qualification to this is a one to many relationship. Okay. The best way to identify that what should be the relationship is when you find two primary keys in a single table. You will definitely find that it should be one to many. Okay, so these are the kind of questions that came in the exams all the time. It's always the same, so no doubt about it. So I just take it out this question, and all of them are so much repetitive, they can easily attain some marks. Okay, so yeah, so this was the ER diagram. Now let's discuss about the normalization process. What is a normalization form? It means that you try to normalize the database in such a way that you can do queries very easily. It could be readable, a process of structuring a relation database and organize table in a manner that reduce redundancy and dependency of data. You can also make good queries, more effective queries, and more organized. It really helps a lot. That's why we need to do in normalization form. So there are 3 stages of normalization. First normalization is when you try to remove those, for example, if you have the data, you have the table, and inside the table there's a one box that have more than 3 data values. In one normalization form, you don't want you want only single data in a single cell. Okay, and there should be no repeated group of attributes, and there should be no duplicate records in one normalization form. In second normalization form, there should be no partial dependencies, and in third normalization form, there should be non-key dependency and no transitive dependency. Okay, let's see what we are talking about. Third normalization form always ensure function dependency, preserving and lossless, increasing efficiency for the running of querying, reduce amount for storage required. Why given set of database table are not in third normalization form. Let's get on with it. So this is the first table, and right now you can see here that in this first cell there are more than one values, right? More than one data, three data values in the inside of one box. So these are not atomic values, and they are also duplicated. They are also duplicated. So we need to prevent that. They are no atomic values. So we need to take out these two and make a separate table. Okay. So in first normalization form, we need to, in order to prevent this, we're going to take these two out, and we're going to make a single table, and then we're going to use the student ID as primary and foreign key to connect these two tables, right? Taking this as a primary key. And so there you have it. This is the table. So you have broken down one table into two tables. Okay, this is the student ID, this is student ID, and you have taken out subject name and subject teacher, as like here, subject name, subject teacher, you have taken out, and then you have made this composite key. So always remember that in first normalization form, whenever you try to make in first normalization form, number one, you will try to take out those columns which are not acceptable, and you just take it out and make a separate table. Number two, you will try to connect these two tables with a primary key. Student ID is the primary key, and number three, it should be a composite key. Okay, it should always be the composite key in first normalization form. Okay, using a foreign key to make two tables. The primary key for the student subject table is a composite key form. The student ID is a foreign key that links to the student table. The subject teacher is only dependent on okay. So having in this way, having two tables and making composite key, and separating it, you have finally achieved first normalization form. Okay, now we're going to move on to second normalization form. And now in the second normalization form, it says that there should be no partial dependencies. What it means that every non-primary key attribute is fully dependent. It should be fully dependent on the primary key. Okay, if that is achieved, then it is into second normalization form. But if it not achieved, for example, not key attributes are depend only one part of the attribute in the compound key. Right here you can see here that the subject teacher is dependent only this part of the primary key of the composite key. So this is known as partial dependencies, and we need to prevent this. So we're going to break it down further into more into three tables, right? First, second, and we will get the third table. So we're going to break it down. We're going to separate this. Separating this, we will get the third table. Okay, the subject name, and the student ID, and now you have separated this subject teacher to subject name. This is how you're going to make the third table, and we have achieved the second normalization form. Okay, now we need to go to the third normalization form. So in third normalization form, we need to have no non-key dependency, no transitive dependency. What is non-key dependencies? Any non-key attribute that is dependent on another non-key attribute. Okay, we need to prevent any kind of non-key attribute which is dependent on another non-key attribute. Instead of that, we want these non-key attributes to be dependent on the primary key instead of depending on another non-key attribute. If there is, then a new table must be defined. And transitive dependencies, which mean changing a non-key column might cause any of the other non-key column to change. Okay, like for example, if you have changed any non-key column, that it could be high possibility that it could affect others non-key column as well. So we don't want this kind of relationship. Okay, so we want all key non-key attributes to be independent, all of the non-key attributes to be independent. So let's do it. So right here, after achieving the second normalization form, we have these three tables, and right here you can see here that the teacher name and location these attributes are dependent on the class ID, and the license number, address, and teacher date of birth is dependent on the teacher name. So you're going to take all these out and going to make another table. So here we have this table. Okay, we have removed these attributes. So there you go. This is a license number, teacher name, address, teacher date of birth, and license number have become the primary key since they all are unique. And okay, now and then we're going to make another one, location. And okay, we're going to take out the location as well, and we're going to connect this to class ID and this to license number. You can see here how they are well structured. This one is connected to this, and this is connected to this. Since having no since the location was dependent on the class ID. Teacher name, okay, so here is a teacher name and here is a location. Okay, and then we have this student ID, subject name. It was already been done, it was already. And then we have the license number. And as you can see here, instead of having the subject teacher, we decided to put the license number as a primary key. And these are the teacher's name, and corresponding, according to these teacher's name and having the license number, we have put the license number in here. Okay, so this is how you successfully come to third normalization form. To DBMS, database management system. So what are the features of a DBMS and what is a DBMS? DBMS is more like let's see, what is a DBMS. DBMS is a system software for the definition, creation and manipulation of a database. It's a system software. Okay, so in a DBMS, it contains a developer interface and a query processor. In a developer interface, it allows the developer to write queries in SQL rather than using a query by example. Queries in SQL, and it gives access to software tools provided by DBMS for creating tables. Okay, creating tables and to write queries in SQL. Okay, and as a query processor, the software tools provided by DBMS to allow creation and execution of a query. Takes a query written in SQL and process it. Include a DDL interpreter, DML compiler, and a query evaluation machine. What is the DDL and DML? We'll see this further. So what are its features? So DBMS will be administered by a DBA for the single universal view of the database. A person who uses a DBMS to customize the database to suit user and programmers' requirements. Okay. Software package designed to store and manage database and providing interface between users and the database. Okay, so software package to store and manage database and providing interface between users and the database. Data management, maintaining a data dictionary. Okay, so having a data management and maintaining a data dictionary. What is a data dictionary? Data dictionary is a file or set of files that contains all the information about the basic database design and all objects which have been created for its use. So it's a set of files that contains all the information about the basic database design, the information about the basic database design and all objects which have been created for its use. The DBMS needs the data dictionary to access the data written in within a database. It contains names, table name, validation, rules, data types, primary keys, foreign keys, relationships. Okay, so that's a data dictionary. And what do you mean by data management? Use a more structured approach to the management, organization and maintenance of data in a database. Okay, data modeling, important tool to show the data structure of a database. Logical schema, a data model, it's a data model. for a specific database, so it must be specific. That is independent. A data model for a specific database that is independent, so it's independent of the DBMS used to build the database. So it's a data model actually. Okay. Another one is it helps to provide data security to prevent unwanted alternation, corruption, deletion, or sharing of data with others that have no right to access it. Definitely one of the most important things of features of the DBMS. Using access right to manage the parts of the database they have access to. Using access right. Oh wow, that's a cool feature. Using only giving certain access to certain users. That's good. Using username and password to prevent unauthorized access. Usernames, and password to the database. Okay, so these are all the features, and this is DBMS, the software tool, the system software for the definition, creation, and manipulation of a database. Okay, so these are DBMS2, developer interface and query processor. Okay, so let's move on ahead. So now we will understand what is DDL and DML, which is found in the query processor, DDL and DML. Okay, so these two are part of SQL. So DDL is used to create. It is used to create, modify, remove the data structures that form a relational database. DML is used to add, modify, delete, retrieve the data, and which is stored in a database. So this is used to create, modify, and remove the data structure. This is used to add, modify, delete, and retrieve the data structures data stored in a relation database. Retrieve the data. Just modify, remove, and modify, delete, retrieve. Okay. So let's start with I guess I'll start with let me start with here. It's much fun. So let's start with DDL, which is used to create tables, create database create database school. Okay, so these are the words, very important keywords, right? Create database school. So this is the table name. Create table student. This is the table name. Okay, this is the table name, and this is the word. This is the keywords. These are the keywords. So first we have to create that. Okay, this is also the keyword, maybe. Create database school. Yes, this must be a keyword. Create database school. Create table school. Create database school. Create table school. Create database. Create table. Okay, these are keywords. Create database school. Create table student. This is a table schools. Table student. Inside database you can have so many tables, right? Now we are making variables. If you guys have done programming, like in Visual Basic, if you have done in program P2 and you are doing pseudocode, you all know what I'm talking about, that these are the variables, and then you're going to find that what is the data type of this variable. So this is a student ID and the data type is varchar. So varchar contains numbers, characters, special characters, so this is a data type for student ID, and this is the length of this variable, that how much you can input. So maximum characters are 6. First name varchar 10, second name varchar 10, date of birth, date as data type. Class ID is varchar 10. Okay, so right here class student ID is the primary key, and we have both primary keys, right? You can make any one of these primary key, and the other is candidate key that can qualify as a primary key. Okay, so we have made this table. We have 2 keys that could qualify, and one of them will become the primary key. Alter table student, add primary key student IDs. Okay, so we have made the primary key, and this is how you try to make the primary key. Alter table, this is a keyword student, add primary key student ID. Okay, so yeah, okay, add primary key student ID. Okay, so we have made this a primary key. Then create table class. We are making another one. Class ID, this is varchar, location varchar, license number varchar, and alter table class ID, alter table class, add primary key class ID. So this is the primary key for this one. Then alter table student, at order table student at foreign key class id reference class id, which means we have made this as a foreign key in the table student. Okay, so we have made this a foreign key and we have the primary key in here, and we have made a reference, which means these two tables, the table student and the table class, is connected through foreign this is a foreign key, this is a primary key, so these two are connected. Okay, it has its own primary key. Okay, now let's go from here. So these were the keywords that I've been using it. Create database, create table, character, varchar, boolean, integer, real time date. These are all data types. These are the keywords for making a database and making a table. Okay, and alter table, which means modify, add a primary key. We use these keywords when we want to modify any, like for example we want to change the data type or maybe we want to add a primary key, adding another data a variable and having the data type. Drop column this, okay, or we could just, okay, there are so many ways to make a primary key. Either we can use this alter table add primary key, or we can just directly use this. We can just put a if you want to, for example, want to make the primary key this one, so I could just write down like says primary key field. I would write it down primary key student ID. Okay, this is what I have done, what I would have done. So primary key student ID. Okay, foreign key field reference table, these are all shortcut, but you can just do in this way as well. Then we have queries. Okay, so these are all DDL. Yes, these are all DDL. You're creating a table, you're connecting tables. And now we will move forward to DML, which is here. These are queries. Okay, when we try to filter out those particular data from the table. So let's start with here. Select column 1, column 2 from table name. Okay, select these particular column from that specific table. Select all. When making a star, it means select all the columns from that table. Select all from customer, which is the name of a table, where country is equals to Mexico. Country must be the name of the attribute or the column name. Okay, where the value would be is equal to Mexico. Select from where is a condition, where you can also use these as well, where country is equals where column having this value and column 2 having this value, where this or this, where this and this, where this or this, where this between this, or where column name is between value 1 and value 2. Okay, then we have order by. Select all from customers, order by country. We are ordering it, making a sequence, and then we'll just try to print out. Select all customer from the customer table, sorted by the country column. Okay, we are just sorting it out. This is why it has been used, order by. Inner join me. So what you're trying to do here is you're trying to select that this column, the this is the orders.order ID. You're selecting the order ID and you're selecting the customer name. Okay, so you want these two columns with respect to when the order that the customer. Select orders.order ID. So order is a table name and it has a primary key order ID. We are selecting it. Select orders.order ID. Okay, customers.customer name. Order and customer are two tables. Order ID, we are selecting order IDs, and we are also selecting customer name from orders. Okay, select orders.order ID, customers.customer from orders, inner join customer. So these two are tables on orders.customer ID is equal to customers.customer ID. Okay, with respect to this condition, we will try to take out these two columns and we will get the whole chart, whole table in this form, like having the customer ID and having having the customer name. We will get the order ID and here we'll get the customer name with respect to when the customer ID is equal to the customer ID of in here of the two tables. Okay, so let's move on. Select record and having matching values in both tables. Okay, now we have this insert into. Let's, for example, if you want to insert values after creating a table, like in here we have created a table, right? Now we want to insert some values. So in order to do that, we will try to use this keyword, insert into table name, employee ID name, values, like in this form, right? You will write down the table name, which is student, and then you will try to write down like this: student ID, first name, second name, date of birth, and then you will write values, and then you will just put down the values. Let's say if you want to delete something, delete from engineering, delete from the table name, delete from engineering where employee ID is equal to this. So you wanted to delete that, so it will delete all the record. Okay, update something, update engineering, which is the table name, set country is equal to Spain, where employee ID is equals to 1. Okay, so this whole thing is data maintenance. So now what we have is here, sum is a function. These are all functions. Okay, select sum, taking the sum of the column name, summing all of them from table this, where condition is this. We can also count, right? Select count column name from table name where condition is this. You could get the number of attributes in the inside a column. Select average column name from table name where condition is this. Okay, like for example, if you're having a table where you have numbers, right, 2, 3, 4, 5, and you want to take out the average of this, so you're going to just put the column name inside here and then table name, and then you put the condition. Okay, you will get the average. Or if you want to count it, you can do the same thing in here. Or if you want to make a sum, you can do the same thing in here. And group by, select column name from table name where condition this is group by this. So you're selecting the column from that particular table, from that specific table, and then put down the condition, and then which is grouped by this. Group row that has the same value into summary rows. Find the number of customers in each country. For example, finding the number of customers in each country. Select count customer ID country from customer group by country. Often used with aggregate function to group the results set by one. Okay, let's say the example for this is written down in here. You have this table, right? We have this table, and you want to select grade, count all as students. So you're going to just take the count, select grade, count all as students from test. This is the table name, test, group by grade. So you're going to group by grade, and then you will also try to, first of all, you have selected these two columns. First one is select grade, and then you have taken count all as students. So I've taken the count all as students from test group by grade. So grouping by grade, you will get this. So group by grade, which means you have this grade, you get, if having A, only 2 students have A, which means John and Alex have grade A. So because of taking the count, you have numbers, right? Count all as students. So this is the name of the column, students, and then count all as students. Okay, B with respect to Lisa having B, so it's 1, and C having Max have C, so it's 1. Okay, so this is the end of this chapter 8, which is database, and thank you so much for watching, and I hope I'll see you guys in the next video. Thank you so much.